began always with an interest in the general nature of matter in the universe, but I did work originally on more restricted problems in nuclear physics and in the construction of various machines like the cyclotron, and also in what is called plasma, the highly ionized gas. And my interest moved more toward understanding the fundamentals of physics and quantum mechanics and relativity. I became especially interested in how these fundamental theories are not clear, that their basic ideas are unclear, and they contradict each other.
Okay, before we get into those contradictions, which I think will form the bulk of our discussion here, as strictly a layperson, one of the things that intrigues me is that it seems to me physics for many, many years ran on the idea that nature could ultimately be understood in its most fundamental way. If we broke matter down into small parts, we'd find out the properties of elementary particles, and then we could rebuild the whole universe. And certainly in biology today, biologists feel if they understand the molecular basis of cells, that we'll eventually be able to reconstruct life. I gather in physics this isn't such an optimistic view anymore. That is, people are finding this may not be so. Could you tell us what that problem is?
Yes. The problem, there are several problems. One is that it is not possible actually to analyze the world into particles. You see, what are called particles, such as electrons, also may behave like waves. Or by something in between, according to the circumstance. They are not predictable, nor do they have the properties that a mechanical particle ought to have. That when many of them get together, they have properties of the whole which cannot be analyzed through the parts. And so that is one point. That's what quantum mechanics says. And relativity also says, in another sense, the universe cannot be divided. And even if we leave all that out, the search... See, physicists, in spite of all this, have generally believed that eventually one could find the ultimate building blocks of the universe. And first they thought it was the atom, with the very word atom means indivisible. And then came the electrons and protons and neutrons, which were supposed to constitute the atom. Then later, the protons and neutrons were found to have a structure they could turn into many other new particles. And now they're supposed to have smaller particles called quarks and partons. And the attempt to find a fundamental particle has continually eluded us. See, every time we thought it was so, it turned out that there was a finer constitution. And also, we have these properties of wholeness to say that the very entities we discover cannot really be understood as particles anyway.
It's all very mysterious. Every time I interview a physicist, and they start telling me about the nature of photons, for example. They have no mass, their energy, they behave like waves, and it becomes a very kind of mysterious universe to me. What are the kinds of problems you found as you began to really delve into the nature of matter and so on?
Well, the fundamental problem was just this one, that we were supposed to consider the world made of particles. The particle we begin with as a small extended object like a tiny billiard ball. And you find that the theory of relativity says it cannot be that. And also, the particle was supposed to move continuously, causally, its future determined, and locally, in the sense that each particle existed in its own space, independent of the others, just interacting mechanically. Right? Now, the theory of relativity made it impossible to hold to the idea of a particle, because if you imagined it to be like a billiard ball, that this would contradict the theory of relativity. It would mean an impulse could be transmitted across the particle faster than light, and that would contradict the theory of relativity. So there were no particles. It was not possible to say the world was made of particles. And to avoid that, physicists went to the idea of a particle of zero extension, a point, a mathematical point. But that led into further contradictions of infinite fields, which have not really been resolved. And the third point is that quantum mechanics shows that the idea of entirely local properties of particles breaks down, that there are peculiar relationships between particles, which are really present both theoretically and proved in experiment, that cannot be understood as a causal connection across the space.
Now, dealing with that kind of difficulty, how do physicists then handle that?
Well, they don't handle it. Essentially, they ignore the problem. You see, that in the old days, people used to want to explain things. You see, now they feel it's not necessary. That if you can find equations that enable you to calculate the observations that we make, it's felt this is enough. That is, one has got to a much more pragmatic approach, in the sense that, although people don't admit it, they say that the main purpose of physics is to calculate results. You see, what they say is that when students first take quantum mechanics, they find they can't understand it. And about a year later, they say there's nothing to understand because it's just a system of computation.
So now I don't understand that. I mean, are people now getting so much into their machines and their analytical tools that the numbers they get out become all important rather than the phenomena there?
That's on one side, that's part of it. See, it's confused because on the other side, people firmly believe that they're going to find the fundamental building blocks of the universe. They feel they're really real. But when it comes to discuss what they mean, they then say, well, they don't mean, they're just computations. You see, I think people haven't thought out the full. Each person does his little bit, the fragments, and each person does his little bit and doesn't worry too much about what's beyond. And he may perhaps assume that somebody else has taken care of it. And so the whole thing just goes on without people generally worrying about what the whole thing means.